This is the Physics 2211 Lab 3. The table of contents, we're going to go over the introduction, the physics concepts, part 1 of the experiment, which is the black hole with the code and result, and then part 2 with the spaceship orbit code and result, and then answer the additional questions. So the purpose of this lab is to observe and study the impact of gravitational pull on orbits and other masses, and then using this data to find the mass of a black hole and to visualize the spaceship orbit around the planet and the moon. The main physics principles are F parallel and F perpendicular, Newton's second law, and Newton's law of gravitation. And the outcome is that we found the mass of the black hole to be approximately 1.4 times 10 to the 34, and we found the initial velocity of the spaceship to be 20,000 or 24,000 and 24,000, roughly those numbers. So for the fixed concepts, we have at the top momentum principle, which is Newton's second law. This is the same as it's been for the past two labs. New for this lab is F-net parallel and F-net perpendicular. These together add to become F-net, with perpendicular being your direction and parallel being the speed. And then Newton's law of gravitation, which is where we take our two masses of our two things we're comparing and we find the distance between them. And we put those numbers into that equation down at the bottom to get the force of the gravity. So this is our black hole code. So we have our V initial and V final vectors and getting initialized at the top. And then this is followed up by actually having to find momentum, which is the mass of the star times the velocity. We then find the change in these, both those, of velocity and momentum, and use that to calculate dp dt, the change over time. F-net is equal to that in this case. Then we come down here and we find our parallel by taking the magnitude, the change of magnitude, and dividing it by the change of time, and then multiplying that by its p hat vector. We then have our F-net parallel is equal to this, and then our perpendicular, since we know that total force is equal to both of those added together, we can just subtract parallel force to get our perpendicular. And then at the bottom, we find the mass of the star. So this is our experiment. We can see it going around in our values there. We take the average of those values and we find that the black hole is approximately 1.4 times 10 to the 34. And then that's how we got our mass. Then we go to the spaceship code. So most of these are all just the same. So I can take the concept from one just to kind of explain it. At the top, we find our distance between the two things. And then we just plug it into that G equation we found. So we do that for the planet to the moon, the ship to the moon, and then we add those together to get our F-net on the moon. And we do that for the planet to the ship, the moon to the ship, and there we go, F-net on ship. And at the bottom, we take our change in velocity formula and our change in position formula, and we put these values into there, and there we go. And this is on the side where we change the ship initial speed, and those are the speeds I chose, so we can get this experiment to show on the right. So we're trying to look at how different things are affecting it. So we kind of see this main orbit primarily caused by the planet in the middle. But every once in a while, which we're about to see right down here at the bottom, the moon will have an effect on the orbit as well, which is why we're getting these three distinct circles. So that's kind of how you can prove that this model is actually working correctly and is correctly affecting the gravity of the spaceship and how things all relate to each other. And technically, every time the spaceship touches the moon there, it changes a little bit as well. So what does this mean? So the net force and the parallel and perpendicular components, just kind of talking about them and how they relate. dp over dt has the relationship with F-net perpendicular and F-net parallel, where when you add those two together, you get dp dt. And as I said earlier, perpendicular is the direction, and parallel is the speed. So together, they both make up the two important parts of dp dt and F-net in our models. And then for the what if we added a black hole and a star to this system, instead of it just being a planet and moon for the second part, we would have to add the black hole and how the star affects the planet and the moon for our model to be correct. We'd also have to add how the planet and the moon affect the black hole and the star. The black hole would be the dominant interaction if this was the new system, followed by the star, planet, and moon, giving us the star, planet, and moon orbiting the black hole, the planet, moon orbiting the star, and the moon orbiting the planet. And that will be the end of my video.